If you're hearing this, well done. We're all proud of you. You have come to the end of this course, essentially. If you have already followed the coding examples, even better. That means you have your own random forest already, and hopefully you will also soon be able to use that in a real business case. If you have ideas for random forest applications in your area of the business, we'd be absolutely thrilled to hear more and discuss together with you. The next thing we need to do now is to also set you up to submit your Kaggle score. Of course, it's a matter of pride now, and you might even be able to beat the 78% that I have shown you here how to achieve. By the way, if your numbers are slightly different, maybe you have 77, 76, or even 80% accuracy with the same settings, that is normal because the random forest gets randomly initiated, so don't worry about that. What is more important, however, is if you find another way of doing it, maybe other hyperparameter settings, maybe some different transformation of the data, maybe you even want to play with a different classification model, and you achieve significantly more than the 78%. That is a true achievement. And if that's the case, based on this course here, please share it with us. We'd be thrilled to hear about it. Before you can go ahead and submit your work to Kaggle, you of course need to estimate your model on the unseen data, on fresh data. To do that, we need to do the same transformations that we did before on the test.csv data. So we, first of all, of course, we read that data and we store it in a variable test. We do that down here. And then we say, okay, we have some function and we call it xTransformer because we want to transform any kind of similar data, similar format to how the train.csv was, just without the survival status, of course, that's unknown here. We want to transform that into looking the same like our x in the end. So I have defined a function to do that. That is really good because then every time I get new data, I can just run the function over this. And this allows me to recycle the code much more. I can also use that for the original x if I wanted to. Here you see the function definition. Be careful when you want to copy that code. This indentation here is really important. Without the indentation, the code will not work. And the indentation goes all the way until down here. You see the same in the for loop and the try concept as well. All that code here you should have already seen. That's just the data transformations we did on the original data. So now that we have the test.csv data in the format that we need to feed it to our model, let's do exactly that. So we use that unseen data, we transform it into a NumPy object because that's what the predict function here expects, and then we predict using our CLF. Remember, that's where we stored the model in, and that prediction we then store in a variable we call preds. The predictions are then transformed into a pandas series so that it looks nicer, and we can also more easily use the toCSV function to store that. And one last thing is we're gonna change the format a little bit of that series. So we're gonna put an index here. That's only so that it's in exact the same format like Kaggle expects you to make your submission, and then you store that into a CSV file which we call testestimates.csv. The names of the headers of that file are also given by Kaggle, so we call it passenger ID and survived. And we say don't use an index because we have already created one and called it passenger ID. Upon submission, as discussed, this achieves 78%. If you have a bit more or less, don't worry, it is subject to random fluctuations. And now with big trumpets and fanfare, it is time to celebrate. That is the end of our course on the AI applicant. Remember, there are three associated coding courses on Kaggle as well. But before we're leaving, let me just give you one number here. If you have a desire to continue, if you find AI is really, really cool, if you make it all the way to becoming a world-leading deep learning expert, your average salary in the US might be around 137,000 USD, right? And these values, they're for real. Of course, there are some absolute geniuses that have significantly higher values than this year, right? But be mindful, if you collect that experience inside the Pro world, you have a few years of real world experience with true deep learning applications, you are on a truly, truly fulfilling career path. And I cannot tell you how much fun it always is for me to create that AI. You've seen a few of the things we can do. No one would have thought just mere 20 years ago we could do anything like this with computers. It's absolutely amazing, almost like magic. With that, let's close for today. We will look into creating more material. There is a lot more to tell you about AI. There is certainly something to tell you about how do you connect with other colleagues, how do you bring your AI into the hands of real customers, and that's why exposure of an API, so it becomes essentially a web address that people can access. And then the last might be the deep learning, where we'll see some of the very, very coolest models of all time.